Okay, lesson 1.1, solving simple equations. You will be able to take notes on this video and with these examples that are coming right out of your student journal. And the ones that you'll start writing on are under extra practice on page 6 of your student journal. So this is, we're going to start off pretty basic here. We're going to do just some basic one-step equations. We're going to be reviewing all of the addition, subtraction, multiplication, division properties of solving equations. So here's what you're going to learn. You will learn to use addition, subtraction, use multiplication, division, and how to solve the real life problems. So the properties, they're all about inverse operations. So if you need to be undoing addition, you would use the subtraction property. If you are undoing subtraction, you would use the addition property, because if you add the same number to each side, it produces an equivalent equation. So it's all about maintaining equality. That's what we're going to be working on. So here we go on page 6, looking at the very first. So I'll kind of model and use the language and words that'll help you to know what you need to do and how to think through the problem. Of course, this is probably like a mental math problem to you. You're like, oh, that's easy, I already know the answer. But we're going to work on the steps to solving the equation and how to show your work in such a way that you're communicating mathematically through your work. So when you go to solve a problem, the goal in problem solving with equations is to isolate the variable. And what that means is to get the variable on one side of the equation by itself. So I always tell students, look at the equation. You can see that they're kind of the equal sign kind of divides the equation into two parts, right? We have this expression, w plus 4, and then on the right-hand side, 16, which is just a number. So what we need to do is to maintain the equality, we need to do the same thing to both sides at all time. So the variable is being added by 4. We want to subtract 4 on both sides. That's how we use an inverse operation. You notice you have a positive 4 and then minus 4 or plus a negative 4, however you want to look at it, and that equals 0. So we've effectively canceled out this number on the left. So I like to draw a line. So W is equal to, and then 16 minus 4 is 12, which you probably knew from looking at the problem right away. But we also want to take the time to check our work, so I'll work through what that looks like too. So we substitute in our answer. We think W is equal to 12, and we're going to substitute that in for W and rewrite the problem and just check to see if it actually is equal. So we really need to check this and say, does 12 plus 4 equal 16? Yes, it does. And since 16 is equal to 16, we know that it's correct. Looking at number 2, the variable is x. It's being added by 7. Therefore, I must subtract 7 on both sides. 7 minus 7 is 0. Always kind of do that extra mental check to make sure that you have a sum of 0 when you're using the additive or subtraction property. All right, so we'll bring down the x. Negative 12 plus negative 7, so we have two like signs that we're adding. We will add the absolute values, so 12 plus 7, and we get 19, and then we keep the negative because it was negative, so negative 19, and then we can check our work. So we have negative 19 plus 7 is equal to negative 12. This is what we're checking, so we have negative 19 plus 7. Since one is positive, one is negative, find their difference. So in this case, we're going to be subtracting 19 and 7. And you always subtract the smaller from the larger when you do that. So 19 minus 7, if you can do that in your head or on paper, however you need to do so. So we get a 12, and then we know it's negative because the absolute value of 19 is greater than the absolute value of 7, and 19 is the negative number. So it'll take the sign of the number with the highest absolute value. And negative 12 is equal to negative 12. On number 3, on first look, it might appear that we need to undo addition, but you have to take a little closer look and notice that 15 is negative. So we need to use the additive inverse, because if I just think, oh, I have to undo addition and I want to subtract 15 on both sides, Negative 15 plus negative 15 is negative 30, and we need the sum to be 0. So the additive inverse is the opposite, right? So if we're at negative 15, we have positive 15. So negative 15 plus 15 is 0. We know that we've done that correct, so we have to add 15 to both sides. So we get W, and 6 and 15 are 21. So check our work. Negative 15 plus 21 must equal 6. It does in fact equal 6. We're good to go. Okay? So that was using the subtraction or addition property depending on which one we needed to do. This is definitely using the addition property, so we will add the number 5 to both sides because we're undoing subtraction in this case. Okay, negative 5 plus 5 is 0, so z is equal to 13. So we'll substitute in that 13 and we'll actually try it out. So 13 minus 5 is 8, and that's what we think it's supposed to be, so we know that it checks out. On number 5, again, you want to see that this is the equal sign. So a lot of people just always start with whatever's on the left. Make sure you're starting with whatever is happening to the variable. So the variable is being subtracted by 9. We want to undo that by adding 9 to both sides. Okay, negative 9 plus 9, we check that's 0, cross it out. So now we can bring down the y, bring down the equal, and we have a negative and a positive, so we'll subtract them. We get 7, and it's positive because 9 has the higher absolute value, and it's the positive value. So we double check our work. Negative 2 is equal to 7 minus 9, and so we do the math over here, 7 minus 9, so it's kind of like having positive 7 plus negative 9, and that's a negative 2, which is what it's supposed to equal. All right. So these all check out. So sometimes when you're writing your work and showing your work, it's always good to circle your answer. It makes it a little easier to see. So I'll do that for you. And if you haven't written them down yet, you can go ahead and pause the video, or if you've already written them down, then continue on for the next example. All right, moving on to the multiplication property and division property. Same thing. If you are undoing multiplication, use division. If you're undoing division, use multiplication. Because as long as you're doing the same thing to both sides of the equation, you'll maintain equality. So we'll just continue on and do 6, 7, 8, and 9 from the student journal. So examining the problem in 6, I see 7 times q is equal to 35. So I want to undo my multiplication with division. So I'm dividing both sides by 7. This becomes 7 divided by 7 is 1. So we get 1q. Okay, 1q is equal to, and then 35 divided by 7, which is 5. So now to check my work, substitute in the 5 for the q. It's supposed to equal 35. 7 times 5 does equal 35. And we know that we've done it right. Okay? Looking at 7, 4 times b equals negative 52. So we want to undo this multiplication with division. It's equal to 1, but we want to divide both sides by 4. So b is going to be equal to, I'm fine if you use a calculator, or if you want to go ahead and do long division, totally fine by me. We're going to get, in this case, because we have a negative divided by a positive, we're going to get a negative 13. So when we check our work, make sure that we're checking it as 4 times negative 13. And we should get negative 52, and we do, right? This equals negative 52, and we know we've done it right. Okay, moving on to number 8. 3 is equal to q divided by 11. So q is being divided by 11. We need to multiply both sides by 11. Oh, that's a terrible multiplication dot. I can't really quite get it thick enough, so oops. Okay. Sometimes I make a lot of little dots there. But we're going to show that we're multiplying both sides by 11. So on the right, the 11s will cancel out, and we're left with q. 11 times 3 is 33. So 33 should be equal to q. We can try this out. Is 3 equal to 33 divided by 11? Mental math tells us that yes, it is. 3 is equal to 3 because 33 divided by 11 is 3. Okay, number 9. N is being divided by negative 2, so we will multiply both sides by negative 2. Okay, negative 2 divided by negative 2 cancels out. We're left with n by itself. Negative 15 times negative 2. Integer rules tell us that if the signs are the same, we would end up with a positive result. So we should equal positive 30. So let's try it. Is positive 30 divided by a negative 2 equal to negative 15? And hopefully it's making a lot of sense that it is, right? Because when the signs are unlike, the answer will always be negative when you're doing multiplication and division. So we've checked it out and it works. Okay, so we've got our answers here. I'll circle those so that they're kind of obvious as to what they are. Moving on. All right, so moving on to some word problems. So the first thing that I want you to do is kind of identify what is the unknown, what is the variable in our equation that we're going to use, what does that variable stand for? Okay, so then the next step is to kind of sort of make a plan. You know, you need to have one or more problem-solving strategies. Some common problem-solving strategies are shown in your note-taking journal at the top of the page, whether it's going to be a verbal model, draw a diagram, or write an equation, looking for patterns, working backwards, make a table. Tons and tons of ways that you can work on this. A lot of what we're going to be doing today is setting up equations. Then you'll want to carry out your plan and then double check. The last question you always want to ask is, does this make sense? So here's our first one. When we look at this number 10, it says a coupon subtracts $17.95 from the price P of a pair of headphones. You pay $71.80 for the headphones. After using the coupon, write and solve an equation to find the original price of the headphones. So we're looking to find this original price of the headphones. And they have already given us this, P is equal to the price of the headphones. So P is equal to price of headphones, and that's what we want to find. Okay. So right here we have a clue because the coupon is subtracting this amount from P. And remember that subtraction is not commutative, meaning you can't put them out of order. So we have to take P and subtract the $17.95 from that because that's how it's worded. And then it says you pay $71.80 for the headphones after using it. So we have the price minus the coupon equals what we pay. All right. So now we're simply undoing a subtraction problem. We'll add the $17.95 to both sides. We double check over here that that's 0. Bring down P. When we add this together, we're going to get $89.75. And then don't forget to use a label because what is it? It is $89.75 that is equal to P, that is the original price of the headphones. And then you can check it. You could take your $89.75 minus the coupon. Do you get $71.80 to make sure that it makes sense? It also makes sense that the original price would be more than what we pay since we were saving money. All right. Final problem. Again, if you want to pause the video and try this yourself and then come back in and check, you can. I'm going to just continue working forward so that the video doesn't get to be too long. So after a party, you have 2/5 of the brownies that you made left over. There are 16 brownies left. How many brownies did you make for the party? So this is what we're needing to find out. We need to know how many brownies we made for the party. So let's make B equal to the brownies that we made for the party. Okay. So we're going to have 2/5 of the brownie, 2/5 of the brownies made left over, and there are 16 brownies left over. Okay. So we can kind of sort of write this. So we kind of sort of have a statement. We have, 2/5 of B would be equal to or is 16. So remember there's some clues here. Is means equal. Hopefully you can kind of remember what of means. So we want to write it like this. 2/5 of B equals 16 because of means multiplication. Now we're multiplying the variable by a fraction. So to undo multiplication, you would divide. But if you can remember the algorithm for dividing fractions, you would keep the first fraction, take the reciprocal of the second, so keep change to multiplication and then flip the second fraction. So to actually, instead of going through all those steps of dividing, we just multiply both sides by the reciprocal of this fraction, right? Multiply both sides. So we're going to multiply both sides by 5/2. Now, these 5's cancel, these 2's cancel. We're left with 1b. Over here, when we cancel, we can simplify first. 2 goes into 16, 8. And 8 times 5 is 40. So how many brownies did we take? 40 brownies. And so you definitely want to put the label with that. Does that make sense? If you take 40 times 2/5, it's like taking 40 times 2, which is 80, and dividing by 5, which equals 16. So you know that works. So always at the last step, ask, does this make sense?